Yes.
Good morning, everyone, and welcome to Engineering Tomorrow's Sound and Acoustics special lab event. I hope that you are ready to reduce some noise pollution today. We're excited to have you here. We are going to hear from an amazing keynote speaker in a little bit, but first, I want to introduce an amazing engineer who will lead the day and hand it over to Miss Betsy Fortman.
Oh, thank you so much, Jillian. It's an honor to be here. Today, we're going to be talking about sound and acoustics. And I know that it was Happy St. Patrick's Day a couple days ago, but I'm feeling just as lucky as that leprechaun to get to be here with you all today. So thank you. One of the first things I wanted to start with is since we're talking about sound, I want you all to take a second and close your eyes and think of a sound that you enjoy hearing. What's something you like to hear or that just reminds you of when you were younger? Teachers, feel free to type in the chat for us and let us know what sounds you all like to hear. Ocean waves and bird chirping, AT stuff, awesome. Mine's the leaves, obviously, with those leaves in the picture there. Rain on the roof. Oh, giggles of babies. Oh, you're right. There's nothing better than that. And today we are going to be studying how sound is created, how we can protect our ears, and just how the sound in our environment can actually affect our health for the long run. So let's get started. You might be wondering, what in the world is this aerospace engineer doing here, right? So I will give you a quick background of who I am. I went to Purdue University and I was sitting in classes not that long ago, or maybe long ago, um, where I remember thinking, why am I learning this? But what was really cool is that I got to work as a co-op where I got to go straight into the classrooms and then I would go to the lab and work. And it was so helpful to have that opportunity to go ahead and tie those things to my job and to why I was learning something. So these are the various vehicles I've worked on in my career. I started off in International Space Station, training our astronauts and flight controllers, what we call the guidance, navigation, and control system. So how we control with respect to the stars, how we do reboosts and deboosts. And so you see lots of different vehicles here. When I came back to the States after being in Russia with our astronauts and cosmonauts, I was helping with these vehicles down here. And I'm pointing these out because this one up here, the space station, as well as Orion, which is a part of the Artemis program, I actually had the opportunity to work with some of the sound requirements that we have on board the International Space Station. And so I'm going to show you that in the very next slide. But before I do, I wanted to give a shout out to Kutztown Area High School in Pennsylvania. You asked, what was your favorite project to work on? My favorite project to work on was the Soyuz. So it's the Russian vehicle that would take our astronauts back and forth to the space station. And typically we have one US crew member, sometimes two, that gets to ride on board with a Russian cosmonaut, and sometimes our international partners. But I loved this because I never dreamed that I would be studying the Russian vehicles. And then I found myself in these simulators with the crew members, helping teach them how it all works. And so that was a really cool career part for me. And then there was one other question. What role do engineers play? And so tied specifically to this lab, I wanted to show you. So that vehicle called Orion that was in the bottom left, this is a mock-up of that. You may hear it called MPCV. And they're basically studying the acoustics inside the capsule because we have to be able to hear with all the fans and computers and other equipment going. But not only do we have to hear each other, but we have to hear if there's a caution or a warning event happening. And we have to be able to communicate to any astronauts doing spacewalks or potentially even to mission control. So that's really important here. The same is true on board the International Space Station. So this here, you can see this is actually on orbit. This astronaut is holding, it looks like a remote control, right? But it has this little device on the end that is allowing sound to be captured through the microphone. And then it is studying like what areas of space station are too loud. Because guess what? All of those fans and computers are running continuously. And then we have these valves that turn on and off things, and they go and make noises too. And so we have to make sure that we're not impacting our astronauts' hearing long term so that they can operate in space and do all the things that they need. All right, so now that you know what some engineers do, even in space, tied to sound, what are we doing today, right? So here's our quick outline. We'll be studying sound fundamentals. What is noise pollution? And how do we measure sound? And we want to measure it because guess what? You guys get to be the engineers today, and you get to design something, a device that's going to help reduce the noise levels. All of our Engineering Tomorrow labs are created by a team of engineers. You can see up here, Travis was our lead engineer helping to create this particular lab, along with our wonderful college mentors, Dylan, Julian, and Caroline as well. All right, so what is sound? I'm guessing you guys have all heard that like joke, if a tree falls in the woods and there's no one around, did it happen? Did you hear it? So sound is created when something vibrates and sends out waves of energy. So all you physics classes out there talking about waves, this is right up your alley. So the vibrations are going to travel. In our case, as I'm talking to you, they're traveling through air, through my microphone into the computer system being translated to you. If you've ever been in a swimming pool and you've tried to talk to your friends underwater, it sounds all garbled. And that's because it's a different medium. And the medium, being water instead of air, is actually traveling faster because the water is way more compact, and then traveling through solids as well. The stronger the vibration, the more energy, as you can tell with my voice. But we also have some other things to study about sound as well. I love this diagram. If there's any of you out there interested in music, you can see the piano scale at the top. That's showing you the different frequencies that are being hit. And pitch is high frequency and low frequency. I like to think of it like a high pitched bird or a very low pitch Darth Vader for any of you Star Wars fans out there. Fast vibration is the high pitched, and low vibration or slow vibration is the low pitch. So you might be wondering, okay, but what can humans hear, right? Well, humans, they can hear around 20 to 20,000 hertz. So just to kind of give you a scale, I like to look at this particular picture. You can see here in this magenta color is our human range, but this is logarithmic. And so there are so many animals who can hear way better than we can. I bet some of you are thinking of some. If your teachers want to type some of those in the chat, I know my dog always hears things before I do, but if you look down at the very bottom of the scale, you can see things like the dolphin and the porpoise. And we're going to talk about how sound affects not only humans, but animals as well. Before we jump in, I want to introduce you to this particular video, and I want you to take note of something new that you learn. All right, and I'm going to have you and your teachers drop it in the chat. What is something you learned from this video? All right, here we go.
This is just some of the noise that I'm exposed to. And that doesn't even include the progressive rock that my neighbors listen to every single morning.
All this noise is really annoying, but it's also killing my ears.
Hearing loss is the fourth highest cause of disability across the world, and it's expected to get much worse. In the US alone, 1 in 4 adults show signs of noise-induced hearing loss. One of the main reasons behind that is all the noise that's around us every single day. According to the Environmental Protection Agency, the best way to protect your hearing is to limit noise levels to 70 decibels. And experts agree that continued exposure to noise above 85 decibels will eventually harm your hearing. If you're curious about the noise levels around you, decibel readers like this one tell you exactly how much noise you're being exposed to. This one's actually fine. I ride the subway for hours every day, and it's really, really loud. But putting in my headphones doesn't really help. Smartphones cranked all the way up are about 100 decibels.
This bar is 105 decibels, and according to the World Health Organization, that could damage your hearing in less than an hour.
This chart shows that the louder the noise, the less exposure it takes to potentially damage your hearing.
All right, you guys, I am curious. Was there anything that shocked you on that particular video? Anything at all? For me, I was shocked at how quickly our ears can have damage. And he mentioned some decibel meters. Here's one right here on my phone, and we're going to be using something similar in your classes today. You can see I'm already at 75, and all I have going is my voice and a space heater. That's crazy, isn't it? Is there anything else that anyone found interesting? Nothing at all. As you're getting ready to type at your keyboards, you just heard about noise pollution and how it is any unwanted or disturbing sound that affects our health. And I love this slide here because it's not only our health that it's impacting. If you've ever thought about the animals, it's impacting them just as much. And so we already heard that anything above 70, definitely above 85, can start really damaging our ears. And it looks like Wilson County has a great answer that 1 in 4 adults have hearing loss. That's incredible, isn't it? And how loud everyday life is. I know, even my everyday life, which is pretty quiet right now, is pretty loud. And it's interesting going back to Wilson County as well. I remember working with a lady who had hearing loss, and it was so difficult for her to even communicate as we were just trying to help serve lunches at school. Because she'd be looking at you, but she wouldn't know what you were saying. And so it actually does impact the person's life. And so this is why it's so important that you guys get to be the engineers today. So down here, you can see the rustle of the leaves, which was my favorite noises. Some of the louder noises that you can see right around here, sounds that reach 85 or higher are going to be damaging to us. And the things like lawnmowers and thunderclaps, those are all much louder at 120 and sirens 120 to 140. So anything prolonged is going to damage that. But how is that damage happening, right? Like we all know it's not good for us, but I don't know about you guys. Sometimes I just love to rock out to some tunes. You can see here in our ears, we have all of these. I want to say it's 16,000 tiny little hairs that are like receptacles. And as they move, it translates into our brain understanding that this is sound. But when we have these really loud sounds, it's almost like when you walk in the woods and you're stepping on some of the grass and leaves and things. Maybe if you do it once or twice, they bounce back, right? They come back up. But if we do it over and over and over again, all of a sudden that grass or in our ears, they're not bouncing back anymore. And all of a sudden we can't hear to the same ranges that we did in the past. So that's kind of like how this all operates. Now, what I found incredible, this is a study in the United Kingdom. They were showing, of course, when there's loud noises, we get highly annoyed. I was shocked to see 22 million people live in a state of high annoyance from sound. That's incredible. But there are other things that affect it as well. Things like heart disease, not being able to sleep at night because certain sounds are going off in the background. And maybe we've trained ourselves to like, oh, that's a train, but still our brain activity is coming awake during that time. And then, of course, we have noise pollution in other areas, not just the air around us, but in places like the ocean. So it can actually impact our wildlife all over the world, not just the ocean. There is some interesting facts that when caterpillars are exposed to noise, their heart rates increase. Another really interesting one, as bluebirds are exposed to high levels of noise, they start having less number of chicks. I could not believe that. What are we doing to our environment and how are we going to protect it? So let's talk about how we can reduce some of those noises. In your workbook, you will be able to find something called a bubble curtain. I put this picture in here specifically because the bubbles themselves, when we release a bubble curtain, it can actually serve as a buffer to whatever noises are going on underneath the water. And so this one's an actual ring that goes around, and when you click it, you can actually hear at the beginning of it, there's like this do, do, do. And then once they activate the bubble curtain, it gets do, do, do. You can still hear it, but it's a lot tampered down. And so check that link out in your workbook today. A couple other things. So now that we know about sound, we know how it's traveling, how can we reduce it? So if you have any ideas, please feel free to drop them in the chat. I'm going to cover a couple of them, and then I'm going to turn it over to you guys in a couple minutes to build your own. If you've ever been at an airport or even along the sides of the highway, you might notice there's like these brick walls, right? So yeah, maybe they're trying to block out what the traffic looks like from the apartment buildings next to it or from, the other side of the airport, depending on where you're looking. But they're also serving as a sound wall or a sound barrier to kind of deflect some of that noise out and up so that it's not going directly into the living spaces of people. And so you can see some of that. Another thing you might see in restaurants or even in like high school gyms or anything like that are these absorbative materials up in this sound, like up in the ceiling, that will help to kind of absorb some of those sound waves so that they're not bouncing off of highly reflective surfaces. In your kit, you're going to have some of these. Yours are actually square, I believe, and you'll have like a 12-inch square of these, but you'll be using some of these very same things that you're seeing on the ceiling to help create your particular design. Another thing that studios do, if you're really trying to do like a recording studio, just like those air bubbles in the air curtain underwater, we can do something very similar in our studios as well. Basically, we kind of build a room inside a room where in between there's air and space to kind of help buffer and cancel out some of that sound. And you can see some of those designs here. You may hear it called a floating floor. It is not because it's floating on water. It's floating because that is like separately isolated from the other floor itself underneath. And so I like to show those. There's also these things called baffles that help direct sound, or gobos, that will help direct sound and kind of deflect it out. And you may want to implement some of those in your designs as well. There is an active noise canceling video that you can take a look at. I'm not going to play it here because it doesn't affect how your design is. Just know that they have two microphones, one that's listening to outside noise and canceling those waves, and one that's listening, another microphone that's listening for your voice and allowing that one to go through. So that's kind of like the principle of that one. And then let's jump right into our lab activity. How about it? Are you ready to design something to help us reduce our noise levels? Every lab, we tend to look at our engineering design process. So you've learned a little here with me today, but now you are going to design in the next hour some mechanism that is going to help cancel out our sound. You're going to build it, you're going to test it, and then you're going to say, hey, is it working or not? What can I do to make it better? So let's take a look at the things that we got. I'm going to switch my camera real quick to show you a little bit about what you will have in your kit. You will have a battery. I have mine taped in here just because I sometimes get a little crazy with it. You should have a couple wires that you'll be connecting to your battery. And then you should also have a buzzer. Your buzzer will have two connectors. Mine is, the connectors are broken right now, but you'll be connecting your circuit up. Now, I should say a circuit comes from the word circle. So think about how the electricity will have to be connected with these wires in a circle to make your buzzer go. So that will give us our sound. The next thing you're going to do, and you can see this in your workbook, here is a piece of that acoustic panel. You can use this or any other items that you have in your classroom. I have found tissues work, tissue paper, paper towels, anything that will help absorb some of that sound, you may want to also include in your design. So I'm going to give you a couple pictures here back on the screen to give you some ideas and get you started. All right, on the screen, you can see the setup. In this case, our students have used a box and incorporated some of the sound canceling acoustic panels inside. It looks like some paper towels as well. And they have directed the sound by beveling out the sides of this particular one. You'll notice their buzzer is on one side. You will be setting it up 90 centimeters. If any of you are like, what is 90 centimeters? It's roughly 3 rulers apart from where you will use a decibel meter. I'm using the one on my phone. You can use your phone, or you can also download them on a laptop if you need that as well. And they should be linked in your workbook. And then you will just be testing, okay, without that barrier, what is my sound level? Whatever sound level you get, you write it here. And then the next thing you're going to do is try to build something in between there in order to reduce that sound and to keep it from getting as high as that level. So that is what we'll be doing. We will be leaving this particular slide up for you so that you can see what it should be. And also try to keep your designs 50 centimeters thick or less and see who can have the optimal design of reducing your sound in your designs. All right, I'm going to go ahead and stop sharing and hand it back over to Miss Jillian, and she will get us started for the next portions. Thank you all so much for your attention.
Fantastic introduction, Betsy. Thank you so much. I think they're ready. So we are going to get ready to open up the one breakout room for you guys to hop into to get to work. And we can't wait to see what you come up with. We will have 2 amazing college mentors in the room, as well as ET staff to assist. So let us know if you need anything at all, and we'll see you back here at 11:30 EST. Have fun.